For this project, we use ResNet50 as heavyweight CNN. ResNet is a deep model learning with 50 layers and skip connection. Skip connection help the model train efficiently and avoid common issue in deep networks like vanishing gradient. Its strong feature extraction ability makes it perfect for spotting subtle differences like telling apart real and AI images.
We use MobileNet for lightweight and efficient and architecture. It's specifically designed for devices or environments with limited resources such as desktop apps or mobile platforms. It uses depth-wise separable convolutions to reduce computation while maintaining accuracy, which make it ideal for fast training and real-time prediction. Because of this efficiency, it is an ideal choice for our project, which is classifying AiArt or RealArt, especially when we are working with a small dataset. It trains quickly, uses less memory, and gives us real-time prediction capability without needing heavy hardware.
For the model architecture ResNet50, the model takes in 256 by 256 RGB image and applies ResNet50 preprocessing to match expected input format. We use ResNet50 model without top layer and frost its wake, so it acts as a features extractor for shapes, texture, and edges. We add a global average pooling layer to reduce the feature maps, a dense layer with 1024 neurons value to learn task-specific patterns, and a final dense layer with 2 neurons softmax to classify the image either AiArt or RealArt. The model was compiled with a depth optimizer and categorical cross entropy loss, then trained for up to 90 epoch using train and validation sets. A debug callback was added to monitor progress, and finally the model predicts the image class with its probability either AiArt or RealArt.
For body architecture MobileNet, the model starts with an input layer of shape 224 by 224 pixel with 3 color channels. It is suitable for color image data. It uses MobileNet V2 as the base model with retained image net width. The top layer are excluded, which is include top equals to false, and the base model is also set as a non-trainable to serve as fixed features extractor. Its output shape is height and width of 7 pixels with 1280 channels or filters. Next, a global average pooling 2D layers that turns the features map into a 1D vectors. This is followed by a dense layer with 128 units and real activation to introduce a non-linearities and learn pattern. A dropout layer with a rate of 0.5 is also added to reduce the overfitting. Finally, a dense output layer with 2 units and softmax activation will produce class probabilities for AiArt and RealArt. This architecture is lightweight, efficient, and well-suited for image classification tasks with limited data and computational resource.
For this project, we use ResNet50 model from GitHub by Alvaro Vasquez. For ResNet50, it has early stopping that monitors validation loss and stop training if no improvement occurs for 3 epochs. It restores the best model weight to avoid overfitting and save training time.
What is special with our MobileNet coding? First is the early stopping callback. It watches the validation loss and stop training if there is no improvement after 10 epoch. This is to help avoid the overfitting and also restore the best version of the model automatically. Second is the custom prediction logic, which is if the model is less than 50% confidence in its prediction, it won't force a result. Instead, it will display uncertainties. This is to help to prevent wrong outputs when the model isn't sure.
For the accuracy and hyperparameter, the testing at image 100 has highest validation accuracy than image 50, which are 0.875. The best configuration at epoch 70 is ideal with batch size 60 and has high accuracy and validation accuracy. The generalization based on epoch 70 has small gap between training and validation accuracy, suggesting less overfitting compared to batch 32. For image 50 has low accuracy but having high in validation accuracy. Non-configuration correctly classify RealArt image for testing image 50 because all image were misclassified as AiArt. It shows the model bias to AI class due to small dataset size, overfitting, and pre-trained bias in ResNet50. So we recommend to increase the dataset size and use another model such as MobileNet because it's better in real eye detection.
The 50 image dataset, the highest validation accuracy was 0.95 with the best setup at input 60 and batch size 16. It stood out by correctly identifying real art with the highest confidence, which is 75.20. For the dataset with 100 images, the highest validation accuracy was 0.952. The best configuration was at input 80, batch size 16, as it achieved high accuracy and correctly identified real art. In conclusion, the 50 image dataset performed slightly better because it's not only achieved high validation accuracy, but also showed higher real art confidence. Despite of having fewer samples, this led to more stable and reliable predictions, which make it more dependable for real-world classification of tasks where precision matters.
Between the model ResNet and MobileNet, MobileNet is a better performing model overall because it not only achieved highest validation accuracy but also correctly detect real art image with greater confidence and reliability. Additionally, as a lightweight model, MobileNet is more efficient and generalized better on small datasets, making it more suitable for practical real art deployment in image classification tasks.